going to do, does everybody go with this? Does everybody have this written down? Yes? Because I'm going to click to the next slide right now. Anybody writing still? No? Yes? Okay. We're going to do some examples using the TV method right now. The first one we're going to do is HCN. I changed this one, it's not number 18. I was going to do 18. I think it's number 14. Yeah, I was going to do 18 for Virginia. Doing 14. Actually, let's do 18. So it's number 14. Okay. Number 14, HCN. So, you're going to start on your sheet. You're going to write out the very first step for TV method. And that is, well, we're going to have T equals, V equals. Well, what's the first step, you guys? You've got to draw out that structure, only single bonds. So, now look, carbon's going to be my center atom here. It's less electronegative than nitrogen. So I put carbon in the center, I put an N over here, I put an H over here, and now I need to fill my octets with only those single bonds. Does hydrogen need 2 electrons here, or any electrons? No, the bond is all hydrogen needs. Now carbon needs 4 more. Nitrogen needs 6 more. Now, the next step, I just count those electrons up right now. That's going to be my T. So literally, whatever number I get down here, that goes right here. So I'm going to count 2, 4, 6, 8, 10, 12, 14. So I put 14 in for T. Next thing I need to do is figure out how many electrons I actually have to work with here. I'm going to figure out so that's going to be my V. So first of all, hydrogen has how many? 1, carbon has, and nitrogen has 5. That's going to give me 10. This 10 goes right here in for my V. I take 14 minus 10, it's going to be plus 4, which tells me I have 2 extra bonds. Now, where am I going to put those extra bonds? Between which 2 atoms? Which ones? C and N, right. You can't have a double bond ever, ever, ever with a hydrogen. It does not have another electron to donate here. It's good like this. So it's got to go between the carbon and the nitrogen. So when I redraw my structure, it's going to be 1, 2, 3, and hydrogen. What's the last step, guys? Fill octets. Always got to fill octets. So we look at carbons first. It already has 2, 4, 6, 8. It's full. What about nitrogen? Sorry, nitrogen has 2, 4, 6. We need to have 2 more electrons here. Nitrogen needs a lone pair. 7, 8. Now my octets are full. Last thing I can check is, does my picture match my V, or the number of valence electrons I should have? So I look at it as 2, 4, 6, 8, 10. That's what I need, right? So I'm good. That's how you can always check yourself. Okay, another one. We're going to do NO3 minus. This is number 19. Correct me if I'm wrong. It is?
Yes.
Okay. is NO3 minus. Perfect. Okay, so first step always is we need to draw the structure with all single bonds and full octets. In this case, which one do you think is going to be the central atom, you guys? N. Perfect. So you write N in the middle, and we have an oxygen here, and oxygen here. Yes, I'm drawing it like this on purpose. They will tend to be symmetrical. Things will tend to look symmetrical. So I'm not going to mark it wrong. Getting us into the next geometry. So now I gotta fill my octets, draw them. So here's oxygen's now full. This oxygen needs 6 more. They all need 6 more. Guys, I'm warning you about this right now. Do not forget about this center one right now. Is nitrogen full right now? No. That's one that people overlook once you start getting better at this and getting faster. They'll forget to put 2 electrons on this nitrogen. So this nitrogen needs 2 electrons as well. Cannot forget about those. So now we total them up. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Our V then. N has how many? 5. Oxygen has 6 times 3, so we have 18. What does that minus tell us, you think? Guys, what do you think that minus is going to tell us? We're going to add an extra electron here. So it needs 1 more electron. We're going to plus 1. So it's going to equal 24, actually. 24. So in here for V, we write 24. 26 minus 24 is plus 2. So how many extra bonds do I have? 1 extra bond. Alright, so let's draw this out. N here. Alright, that's what it's going to look like. We need to, what do we got to do here now? We got to fill the octets. Always, always, always the last thing is to fill octets. So how many electrons does that oxygen need? How many more does it need? It needs 4 more. It's 2, 4. We got to put 4 more here. 1, 2, 3, 4. This oxygen needs 6 more. This oxygen also needs 6 more. Does nitrogen need any more? No. Good. What is a question you might be asking yourself or asking me right now? What are you wondering? Does anybody? I know somebody is.
I didn't know what one to put.
What, Kendall?
I didn't know what one to do 2 lines.
How do you know which one to do 2 lines to or put a double bond to? The correct answer is you don't. But what you need to do is you need to show all the possibilities. So what you're going to do is you're going to make an arrow like this between back and forth because it could be either one here. You're going to write your N in your middle. Now you're going to have a double bond to the oxygen on the left. You need to fill octets for this one too. We're not done yet though, we still have one other possible structure here, and it's going to be a double bond to the O in the right corner here too. We put N. Always, 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 we must fill the octets when we're done. So this oxygen needs 6 more electrons, this one needs 4 more, this one needs 6 more. So I cannot forget to do that. I'm still not quite done. There's one thing I cannot forget about here. That's that minus from the start. what I need to do is, I'm going to put a bracket around the whole thing here. And then I need to write minus. Tells me I have an extra electron here. If it was a 2 minus, guys, you write 2 minus there. If it was a 3 minus, you write 3 minus there. If it's a plus, you write plus there, whatever it is. Guys, we still got some stuff to get through, and I'm going to do some examples from your homework too, your other homework. All right. What that's called is, and this is where it says resonance on your sheet, that is called a resonance structure. And in simple definition, it's when there's more than one possible structure. And it usually involves double bonds. Could be triple bond too, double bonds, triple bonds, whatever. We're not going to do that. We're going to do number 2 on here. It's N2O. This one's not on your worksheets. So if you want to follow along with this one, you might have a little bit of space there underneath resonance. Otherwise, you can write it in your notebook, or you just follow along. Alright, I know Mr. Black is passing it out, you guys. I need to keep going and pushing through while he's passing it out, so you need to pay attention while you pass that paper down right now. So we're going to do N2O. We gotta first do our T and V. So we need to figure out how many electrons are there with all single bonds in Filioque Test. First I need to know what's the central atom. In this case, guys, I would probably tell you what the central atom is because you have a competing things here. Because, first of all, there's one less oxygen, right? So there's more nitrogens, but what do you notice about nitrogen's electronegativity? It's less electronegative. So what's going to actually happen is that there's going to be an N in the middle here. But we would tell you this. So we're going to have N bonded to an O, bonded to an N on the other side. This is a more challenging problem, that's why I'm showing you it right now. So you don't get caught on what you're doing. Alright, next thing we need to do is Filioque Test. So this guy needs 6. The middle one needs 4 more. This guy needs 6 more. Okay, count them up. We have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Now, I need to figure out what my B would be. So, I have 2 nitrogens. What's nitrogen?
5.
No, not the atomic number. It's in 5. 5 times 2 is 10 plus 6 is 16. That's going to be my B. 20 minus 16 is plus 4. How many extra bonds do I have? 2 extra bonds. So what's one possible, where can my extra bonds be here, you guys? So, So there could be one where each bond already is. Sure. I still got to fill my octets here. This oxygen needs 2 more. This nitrogen needs 2 more lone pairs as well. So now we can count it up. We have 2, 4, 6, 8, 10, 12, 14, 16. That's how many we need, right? It equals our V. Is that the only possible structure here? No, what else can we do? Triple bonds. Exactly, we can triple bond here. We make an arrow. We could have N triple bonded to the other N. And then a single bond to oxygen. Now to fill this octet out, we just need 2 electrons here. And we need 6 on that oxygen. That's still not it, is it? Because I can still have a triple bond to the other oxygen. Or to the oxygen, sorry, to the other atom. Alright, awesome. We're going to do 3 examples from your sheet. Right now. 3 examples from your worksheet. The one you just got. Yes. Don't make fun of me. It's good. Andy knows what I'm doing. Great. Yes.
I might have seen you eat. I've been watching you. Everyone.
Yeah, I told Oh God. It's cold. Yes. That's not a bike. It's not a bike.
Yeah, you're over someone.
You just take it out.
It means you have a double bond. It means you need to put it on. Generally speaking, you do a resonance structure. All 3. Okay, thank you.
I fixed it.
I was gonna say, I'm like, wait, now the time's right. I was expecting there to be less time, that's awesome. Okay, cool. So, we're gonna do number 2 first. Number 2 is SO4 2 minus. We're always gonna do T and B. So the first thing we can do is we're just gonna write S in the middle, bonded to O, bonded to O, bonded to O, and bonded to O.